And welcome to the Daily Space Weather Show. We've got some wavelengths and imagery that we don't normally show on the channel, as things will get more and more interesting as we ramp up and up to solar maximum. We're not going to call out the nature of each set of images. They are typically in the time and date stamps down in the lower left. If you're watching shorts, make sure you view the entire video. So these are 24-hour videos from Solar Dynamics Observatory. And we've got fairly similar levels of activity to yesterday on the Earth-facing portion of the solar disk. There's a little closer view, much of the same. Some new minor sunspots showing up in the east, but for the most part we should have another decline in sunspot number going into tomorrow. Here's some difference imagery. Once again, we've got the running 60-minute difference for the 193 angstroms wavelength and the 304 angstroms ionized helium wavelength there in regular, no difference imagery. There's the full disk view in those same wavelengths. Great at showing filaments and some depth in the lower corona, especially via the 304 angstroms wavelength. Let's take a look at sunspots here briefly. Again, no major changes since yesterday. A little bit of growth showing up in the east. So, yeah, it looks like that one actually grew there. It just kind of formed. It didn't actually rise, I think. Should be able to see some happenings there in the colorized magnetogram imagery. Those groups in the north do not appear to be sunspots at the moment. We will show high-res imagery of those later in the video. Let's do a brief volcano rundown. Suwanosejima is erupting, producing a 6,000-foot ash plume. Ibu, 7,000-foot ash plume as Ibu explodes. Luotobi exploding as well. 8,200-foot ash plume over Luotobi. You can find some imagery there of those volcanoes if you like at volcanodiscovery.com. Merapi also exploding, flight level 140. That's a 14,000-foot ash plume. 7,000-foot ash plume at Dacono. Headed down to Central America, Sancha Guido, 15,000-foot ash plume. Emissions continue at Fuego. Nevado del Ruiz, no observed emissions. Revenador, sporadic emissions, and Sabancaya producing a 24,000-foot ash plume over Peru. Please do not pole vault the caldera. And let's get to seismic activity. If you're going on a volcanic vacation, leave your vault pole at home. These are the erupting seismic activities. That's the past 90 days, also courtesy of volcanodiscovery.com. And here's our USGS map. We'll call out quakes of a 5 or greater magnitude. First of all, a 5.3 in Russia. Central Asia there, near Kerensk. 5.3 occurred at 5:09 this morning. And moving up the list here, a long period of no 5 or greater magnitude quakes until it's broken by a 5.4 at the southern East Pacific Rise. And a very desolate portion of the planet there at 1536 this afternoon. Then Reykjanes Ridge, the part of the Mid-Atlantic Ridge there, well south of Iceland, at 1540. A 5.0 there. Some minor quake activity in California, a 5.0 at Indonesia. That was at 1852 this evening, and then finally a 5.7 at the South Pacific Rise. And that was the largest quake of the past 24 hours at 21:33 Universal Time. Next, some space stats. So first of all, the 10.7 centimeter radial flux is now at, I have no idea. I have no idea what it is. 149 solar flux units for the radio flux. If you're wondering where it comes from, we made this animation to maybe help. I don't know. Maybe it'll help. Maybe it'll help. Maybe it won't help. It comes out of the upper chromosphere and lower corona. So it's the most proportional data set we have to sunspot number, and there you can see how proportional they are. If you look at the red line versus the black line, that's the past year. Radio flux in the black line, sunspot number in the red line. Radio flux now at 149. Space Weather Enthusiast dashboard forecasting a little bit of possibility of geomagnetic unrest tonight, so fingers crossed for that. For all of you aurora chasers, we may see a little minor uptick. Can I speak the English language? A minor uptick in the aurora this evening. No major storms forecasted, though. It's looking like a minor CME impact is somewhat likely. Pretty diffuse plasma, though, so only expecting KP4. I would tend to agree with Noah on this one. Probably won't see more than geomagnetic unrest. Next, the past 4 hours of Earth's magnetic moment from space. Here's our geospace magnetosphere movie. And sometime relatively soon, we do expect to see a little bit of an uptick in the solar wind parameters, and hence the plasma pressure, the magnetohydrodynamic pressure depicted in this imagery. You should also see some feedback in that. You'll also see feedback in this, the ground magnetic perturbations map. If you want to follow the aurora, by the way, the most likely places to see it, there are many different features that you can view at the Space Weather Prediction Center, or SWPC. Past 4 hours of Earth's magnetic moment from space and the ground have been calm. KP index is currently at 0.67. KP 0.67 is the current average of global geomagnetism. Let's look at solar wind parameters here, measured at Lagrangian 0.1. Those are the measurements by the ACE spacecraft, which has a huge area of missing data there in the past 24. Current solar wind is fairly nominal and pretty diffuse at the ACE. At the Discover, a little denser, around the same speed there. So solar wind around 450 kilometers per second. Solar wind density here about 7 protons per cubic centimeter. GOES magnetometers are smooth, and we don't expect to see any major variations in that either, with no major geomagnetic storms likely this evening. Next, our top view ecliptic plane field plot, one of the best predictive data sets that we have. And Earth is still kind of right toward the middle of a South Pole-oriented sector. Shown there in red, that's the situation from the Earth Magnetic Heliosphere Station. Here's our line-of-sight ecliptic plane field plot. Expect the southern polar sector to remain Earth's magnetic sector for an ongoing period of time here, at least a couple of days. Next, our line-of-sight field plot, showing you a lot of things all at once here. The photosphere magnetism in grayscale, B field in blue, and the polar fields in green for north and red for south. So that is just a spectacular series of images for you there. And here's our line-of-sight coronal hole plot. And the feature that you'll be hearing about all over the space weather interwebs should be coronal holes. If people are doing their jobs correctly, they'll be talking about coronal holes, which are the source of high-speed solar wind. And by the way, if you're interested in asking a particle physicist a question as to what mechanism could possibly be accelerating those solar protons to create the fast solar wind that comes from coronal holes, perhaps you'd like to participate in our Ask a Particle Physicist segment. Here's a great close-up of that coronal hole. It is a transequatorial one, so we are expecting an uptick in the solar wind parameters here in about 4 to 5 days. And it looks like it'll be fairly distinct in terms of the coronal hole wind onset and then the ramping down of it. Here's an extreme close-up. And what we're showing here is the 193 angstroms difference imagery along with the 211 angstroms raw imagery. So just great views there of coronal holes. The extreme close-up. And that makes it time to head to sunspots. So sunspots are next on the agenda. There is what Rob has to say about it. Sunspots have dropped way down here to 80. About 80 sunspots is the current number. Flare probability not that high. The most likely place to see large flares remains at the western limb. It's been very quiet as far as flaring for the past day or so. Only C-class intensifications, and let's take a look at sunspots. So here we've included the 171 angstroms difference imagery along with the SDO's continuum imagery. And here we'll subtract the 171 angstroms to reveal just the sunspots. There you go. There are just the sunspots, more or less the SDO continuum. Again, a couple of new sunspots have formed there in the southeast. Those light spots in the northeast are just plages. We don't see any dark umbre yet. So, also some new sunspots formed up here. Oh, those are just stable. Never mind. Those aren't really new. And let's move on to energetic particles and flares. So goes proton flux here at baseline levels. No significant solar energetic particles to report. Again, X-ray flux has been declining here for days. Background flux now about C7.5. Background X-ray flux now about C7.5. And here come our favorite wavelengths through which to view flares. There's 131 angstroms from SDO. And let's switch things up here. We're going to switch to the 131 angstroms difference imagery and show the raw images for 94 angstroms. Again, the most likely place to see a large flare is going to be in the western limb, although there is a promising sunspot there in the southeast. So most likely is the west. Next likely is the southeast. Flare watch continues there on the western limb as there are still significant sunspots that are setting, and it's hard to tell what they're doing because sunspots can still produce large flares when out of view. So obviously you can't see their magnetic fields when they're out of view. And let's move on to a star chart. You want to know what's going on overhead? I often do, so I consult skyandtelescope.org. That's not an official endorsement. They may have no idea that our channel exists. I wouldn't be surprised if they didn't. You've got the constellation Cygnus up there, though. One of the more interesting stars in the galaxy, indeed, is Deneb, the tail of the swan. Anyway, you've also got the Moon and Saturn up there right now over Lehigh Valley, Pennsylvania. The Moon having just come over the horizon as Deneb circles Polaris all winter long. Continuing right along, it's time for the solar system forecast. You want to know where things are today? Well, there you go. That's theplanetstoday.com, by the way. And if you're wondering what these spooky purple glows mean, see those spooky purple glows? Oh my God, look at that. They're glowing purple. That means that they're in retrograde. They're moving the opposite direction in relation to the rest of the background stars. So that's how planets got the reputation as wandering star. It literally means wanderer, planet. So anyway, that's what it means. This is where things are today. Let's advance this into next year. That's where things will be in 1 week on the 3rd of January as time continues running out. Is it running out for your soul? Is your soul treading water in the river Styx because you failed to press the like button? I certainly hope not. Here's our astronomy photo of the day. Rainbow aurora over Icelandic waterfall. It's pretty sweet. Also Andromeda Galaxy, Milky Way Galaxy, Iceland, and the Pleiades. Fantastic imagery there. It looks like it could be the cover to the next Yes album. And leave a comment, yes, if you would buy the next Yes album. Yes, I know hallucinogenic tourism is now back in style, as it is legal in Denver, or something. There's some kind of thing about the... Anyway. No, Yes has not announced a new album that I'm aware of. Although type yes in the comments anyway. Some long exposure photography there. And let's move on to CMEs. It's about that time. Here are CMEs from yesterday. That's 105 frames. Dear God. 105 frames. Here are an additional 88 from today. And we may have some earthly directed CMEs, but they are once again minor ones. Speaking of minor ones, the sun is being a plasma miser. It's been withholding plasma throughout the solar cycle. Maybe a little bit at least. Anyway, let's check out those CMEs from also the C3 there, depicted on the right. And let's zoom in a little bit closer here again, because there may be two minor earthly directed CMEs to add to the list to show up at Earth just before 2024. So there's still just enough time. I do believe two of those are or have earthly directed components. I'll just say that. So let's take a closer look here. Here are CMEs from that's our 24-hour SDO video, 193 angstroms, and the synchronized C2 and C3. So there are two events that happened earlier today. One is that one there, and the other one is that one there. So I suspect both of those may have earthly directed components. We can expect those to begin to arrive sometime around the 30th. Or maybe the 29th. So sometime after midday the 29th into the 30th is when we would expect to see those arrive. And you'll see one, it looks like came from this area right here. And then the second one came from this active region right here, just south of center solar disk. So again, two minor CMEs, coronal mass ejections, are likely on the way to Earth. They're likely to arrive sometime after 12 noon Universal Time on December 29th. We won't expect any major geomagnetic storms for those either, only minor. Nothing above a KP 5.33, I would say, from those. First one looks like it is a little higher speed, perhaps. So it might even arrive early in the day on the 29th, but I would say sometime after midday in the 29th is the safest bet for that. Again, one event came from this area right here, I believe, and the other one came from this event down here, the later one. So there is some great difference imagery once again. Difference imagery in 304 angstroms. The raw extreme ultraviolet imagery there in 193 angstroms. Shows a lot of different features there. Filamentary motions, coronal holes, prominences, active regions, and the extended corona. Next, moving to filaments. And here are filaments from Cerro Tololo, Spain. And there may be some new active regions rising down there in the southeast. I see some large filaments down there, some prominentiary ones. You see those? Those are prominences, which are the same feature as these, just hanging off the edge of the limb. So here's the color imagery. And yeah, likely some new active regions to rise down there in the southeast. If I had to bet, which I certainly don't. And before we get to bonus features, here are the latest images from the GOES 16 SUVI in 304 angstroms. And it's time. Time to do bonus features. First, satellite charging hazards. There aren't any at the moment. No surface or internal charging. No high-energy electrons building up inside of, and no low-energy electrons building up outside of spacecraft. Goes electron flux here in a normal operating range. That's the past 3 days. Let's show a 7-day chart here just for the fun of it. There you go. There you can see what a minor electron storm is like. Here's the 1-year graph. There you go, the relativistic electrons for the past year. Next, the layer where they're measured, but first the forecast model. And we are expecting a much lower observation there on the next update. So, if we do see a minor geomagnetic unrest, we should see a dip in the electron flux there. We should see a dip in the electron flux tonight, an anomalous reading caused by the incoming CME. We'll also show the layer where it's measured, which is the F layer. Feel free to pause the video on this frame if you're not familiar with distances in kilometers. There is the animation of the vibration of the F layer. We'll also show the anomaly in megahertz from a 30-day median. The bridge between Earth and space. It is essentially space for all of you air breathers. However, there is gas there, and it is vibrating at certain frequencies. That's what we're showing here, and you'll see this in tomorrow's video showing a bit more red toward the beginning we would expect with the minor incoming coronal mass ejection impact. So that's what's going on at the F layer. There's the latest 2245 universal time. We'll also show the whole atmosphere model, or WAM, the global atmosphere nowcast. The global ionosphere nowcast, rather. Radio operators will like the right images. GPS users might benefit from the left images. We'll also show total electron content by itself before we close out space weather. Total electron content is free electrons to about this altitude, about 12,500 miles, the inner portion of the outer Van Allen belt. There you go. There's the total electron content. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model. These are the locations to expect errors in your GPS. We'll close out with the latest magnetogram and intensitygram. There you go. There's that southeastern limb. Again, these groups in the northeast are not sunspots yet. There's the full disk rockback. And let's get to meteorology. It's time. Time to move from space weather to Earth weather, since time is running out. So, it's time for meteorology. Yes. We haven't actually shown sea surface temperature anomaly for a while, so here are the surface winds and sea surface temperatures anomaly. So there's the Atlantic Ocean, here's the Arctic. Let's don't forget the Pacific. Just the world's largest surface heat sink, because that's a lot of water. Here's the Antarctic, the Southern Ocean. And let's don't forget the Indian Ocean. There you go. That's what's going on with sea surface temperature anomalies and surface winds. Now we'll show the surface winds again here. There is the surface wind scenario for the east. There is the jet stream scenario for the east. Jet stream scenario for the central world. Surface winds. Surface winds of the west. And the jet streams. We've got a strong upper level low right here over the north central U.S. That low right there, you can see this obvious clockwise rotation there, the telltale sign of an upper level low in the jet stream. Let's take a brief look at snow, as I'm interested in what the current status is. And the current status is there's a lot of snow water equivalent. The snow extent is well below the -1 standard deviation mark, well below in terms of snow extent, the two-dimensional amount of area that the snow covers. And then you've got the snow mass balance, which is right in the median right in the center of the graph there, that's the average from 1982 to 2012. Snow mass balance is the actual mass of the snow there, not including mountains. Continuing on to clouds and fog for the Americas. As it clouds up once again, every night it clouds up over Brazil. What's up with that? The sun sets, the clouds come out, and the lightning begins to strike. Here's what's controlling the weather over the U.S. This low right in the center, well, near Lake Michigan actually, but it's kicking up a bunch of moisture into the mid-Atlantic states where we're located. And if you want to visit some of the best cycling roads in the world and one of the best cycling communities in the world, come visit us in Lehigh Valley, right about there. Just splentacular bicycle riding. Next, our snow cover map. And I don't want to look at snow cover. I want to look at something else. How about precipitation type? There we go. So a little bit of snow here falling over places like Nebraska, Minnesota, and South Dakota. Precipitation type, one of the many features of windy.com. Weather.gov shows some flooding likely coming to the Garden State as well as the Keystone State. Those are New Jersey and Pennsylvania, respectively, if you're keeping track. Weather.gov is where to get your weather warnings. And Tropical Tidbits is where we got these forecasts, so maybe go give them a shout out. Levi Cohen over on Twitter. That's a 72-hour GFS pressure and precipitation forecast. As we get more rounds of rain coming to the Lehigh Valley, Pennsylvania, making it, shall we say, a bit dreary. Next, total accumulated precipitation in inches. Same model, GFS 72-hour. Last but not least, temperature anomaly forecast in degrees Celsius, GFS 72-hour forecast. Warm times for places like northern Minnesota, Wisconsin. Again, remember that is in degrees Celsius. So if it's showing 20 degrees above normal, that is very warm. Next, lightning. But first, once again, tropicaltidbits.com. Tropicaltidbits.com. There are the last about 10 hours of lightning. As you can see, lightning just spreading across Brazil. Here's a real-time lightning map, courtesy of lightningmaps.org. And the most significant thunderstorm is currently in the central subtropical Atlantic. So there are some existing strikes. Looks like a bad day to be on a boat with Marky Mark Wahlberg and George Clooney, wouldn't you say, Smash Staff? It could be the perfect storm. Oh, dear God, not the perfect storm. Oh, my God, what am I going to do? Here's what I'm going to do. Recommend that you visit our websites, like smashomash.com. We built our own because we saw the writing on the wall of the certain things going on social media entities back in 2019, so we launched our own website, to benefit people like you. Smashomash.com. Visit our links, help support the channel, and don't forget to press the like button. Press the like button. Press the subscribe button if you're new to the channel. Do yourself a favor. Get the world's most comprehensive daily space weather content and most detailed solar imagery delivered directly to your subscription feed. Or become a member of the Smash team and get email alerts about videos just like this one. I don't know. But make sure you press the like button, or else time will be running out. Not just for the year, but for your soul's ability to tread water in the river Styx. Is that what you want? A sinking, stinking river Styx soul? Nobody wants that, of course. So press the like button and avoid all of that nonsense. We'll close out the video with U.S. Doppler radar. You can see that low is right over Missouri right now. And a bunch of foul, putrid wintertime moisture is rolling over Pennsylvania, not producing one flake of snow, at least not in this portion of the state. Just a dreary, gross, putrid 40-degree day. Not a fan. Not a fan. Anyway, there's the full 50-state view. Here's the lower 48 view as we bring your space weather and Earth weather together in epic fashion. There is clouds and fog for the lower 48. Great view of that low. And once again, you'll be able to see it here in the water vapor map just as well. This is sort of what you'd call an atmospheric creek right here. That right there is an atmospheric creek. Not to be confused with an atmospheric river, which is more like what this is. A lot more moisture there rolling off the Pacific as the Gulf of Mexico is cooling down. Anyway, here is your recap U.S. Doppler radar. It shows vertical motion in the air column. Space-based systems show infrared radiation at 3.9 micrometers. And there's the water vapor map. It shows the dry air, the moist air, and everything in between. And here is me. I've got to lean on the hatch in order to open it because I am headed back to the bunker. I'm going back to the bunker again. All the stupid stuff I heard encouraged me to climb in. How?